Okay, so this video we're going to do repeater integrals. Now you're going to see why it's called a repeater integral in a little bit, but for one, I noticed that it's a product of two functions. So I'm going to use my Lie8 mnemonic, Lie8, and I see that I have e to the x, which is an exponential, and I also have sine x is a trig, and so Lie8 tells me what u to pick, whichever letter comes first. So u equals sine of 3x, and dv equals e to the x dx. Okay. Now I'm going to run through the process here. Du, derivative of sine 3x, is cosine 3x times 1/3, chain rule. Derivative of 3x is 3 dx right there. Okay, and then the integral of e to the x is equal to e to the x, so that one's not too bad. So what am I left with? I'm left with the integral u times v. So remember, it's the integral of u dv equals uv minus v du. Always think of the second part as voodoo, because we're doing voodoo math, okay? So that's how I remember v du on that second part. So however you remember it, I don't care, right? So, but that's kind of how I think about it. Okay, so u here was this point there, and v is this e to the x here. So uv is sine of 3x times e to the x minus v du. So v is e to the x, and then du, that's 1/3. Oh, what have I done here? That's not 1/3. I'm sorry. This should be 3 out in front. Okay, so that should be 3. So look, the derivative, so sine of some stuff inside is equal to the derivative. So that's cosine of the stuff times the derivative of the stuff. Well, the stuff is 3x, so the derivative of that stuff is 3. Sorry about that. I was looking there and I was like, something doesn't seem right. Okay, so this is going to be 3 cosine 3x dx, right? So what do I have? I have the integral of e to the x sine of 3x dx equals e to the x sine 3x minus the integral. Now it's 3, I'm going to pull that on the outside, and I have what? I've got e to the x cosine 3x dx. Okay. So now I need to do another integration by parts here, because this isn't just one of those regular rules. So once again, I'm going to pick the trig to be my u. So u equals cosine 3x. du is equal to negative 3 sine 3x dx. Got my chain rule correct that time. Okay. And then dv is e to the x dx. So v is e to the x. So I'm going to rewrite this part here, down here, and then my 3, and then I'm going to box in. So it's uv, which is e to the x cosine 3x, minus v, integral v du. Okay. So what do I have? I have the integral e to the x sine 3x dx equals e to the x sine 3x. And then this negative 3 transfers as minus 3 e to the x cosine 3x. And then minus 3. Okay, how many minuses do I have got? 1, 2, 3 negatives make a negative. So that's 3 and 3, that's 9. So minus 9 integral e to the x sine 3x dx. Golly, what a mess. Okay, and now I'm sitting, I'm looking, I'm like, oh my goodness, e to the x sine 3x. I still don't have a rule to that. Well, you kind of see here, you're in an infinite repeat loop. Why? Look over here, it's the exact same thing that's over here, right? I literally started out trying to figure out what the integral of e to the x sine of 3x dx is, and somehow I got it equal to some stuff minus 9 times that same stuff that I started with. So how's that possible? This is why we call it the repeater integral here, okay? So why is this a repeater? Well, when you think about this, how you're picking your u's and your v and your dv's, I keep taking the derivative of e to the x, it's never going away. I keep taking the derivative of sine of something, it's never going away. So it ends up repeating on itself is what's happening here. It's just differing by some constant multiple. So how do we solve this? It's really pretty ingenious, right? So we don't know what this thing is, right? So if we called it like blop, right, equals this stuff here. Don't write this down, just watch, okay? Equals this stuff times, and then we have the blop again. Well, how would we solve for the blop? Well, it would be the same way as if that blop was like, instead of a blop, maybe it was just like y, right? If we're trying to get y by itself, what would I do? I would add 9y to both sides. Okay, and so I have 10y equals this nasty stuff here. Okay, and then how do I get y by itself? I divide both sides by 10. And voila, I've got my answer. So that's exactly what we're going to do here. Okay, so what am I doing? I'm going to take this integral here. I'm going to add it, 9 of them to both sides. Okay. Sorry you can't copy and paste yours like I can. But if I add, I have 1 of them here and 9 of them there, that makes 10 of them. 10 e to the x sine 3x's equal to, well, what do I have left? I've got this, got that piece there, okay? And so what do? I'm going to divide both sides by 10. And then I'm going to do my plus c. Okay, so the integral of e to the x sine of 3x dx is equal to e to the x sine 3x minus 3 e to the x cosine 3x over 10 plus c. How cuckoo is that, right? Isn't that crazy? Like, that's so cool how that ends up working out, right? So that is an example of a repeater. Okay, repeats. It just keeps on repeating through.